Hi everyone, my name's Chris Guy and I was a senior marker in charge of looking after Standard 1 and Standard 2 questions that are up on your screen. So what we'll do is we'll go through areas of weakness that the kids showed, where they can improve, and some general ideas moving forward. So hopefully you'll get something out of today's presentation. Okay, so we're going to start with the Standard 1 questions first up. Now these were not common, but some of the Standard 2 questions that we're going to look at later were common with advanced. And just to give you a heads up, I'll only talk about what we saw with the standard responses, not with the advanced. Okay, so the first question with Standard 1 is question 11. Now, with it being one of the very first questions, you can notice with each of the slides I've got up there, I'm going to have the sample answer, what NASA have provided, along with the marking criteria. Now, for this question, what the kids were expected to do was to justify their answer with calculations, comparing them to the 100 grams. Now, with the sample answers, they are ways that we were expecting to see the kids solve it by converting them all to 100-gram comparisons. Now, what we did see, the better kids were actually able to identify 100 grams for each of the packets, but we didn't see that often. So other kids were actually converting them to different units, not necessarily to the 100 grams, but they did show some sort of understanding about how to convert from one unit quantity to another. Other students were able to correctly identify their correct option based upon their calculated values. So the kids may have been able to incorrectly calculate a comparative value, but they were able to identify from their values what they would then consider to be the best buy. Now, common errors with this particular question were, we don't think they actually read the question clearly enough to identify what unit that they needed to be compared to. So the 100 grams was what we're all after, and that's what NASA provided. But kids were converting them to the nearest gram, to a kilogram, etc. So the students did have an understanding, but they missed the point where it was meant to be done to the 100 grams. Conversely to that, they weren't able to actually justify their final selection. So the kids might have randomly chosen what they thought was the best option, but they weren't justifying their response with any sort of calculation. So again, we don't think that they either read the question clearly or understood what the justification was in terms of the maths here. Now, where we want to move forward and what we think that the kids need to be aware of is obviously being able to convert values from a range of rates. So this was one example in terms of best buys. And again, look, we've done best buys. It's part of the syllabus in the junior years, but maybe not understanding what the best buy means, and then obviously how to calculate and justify what they thought the best buy would be. So overall, yeah, there were a few little things that went on with the kids here, but the 100 grams and calculating it to the nearest or to the correct 100 grams was probably the biggest key to take out of this particular question. Now, the next one in Standard 1 that we looked at is question 12. Now, question 12 for 3 marker was actually quite complex and quite detailed for a Standard 1 student. There were a number of areas that the kids needed to calculate, and what we did see again, and I'll go through this in a minute, was the kids seemed to get muddled up in terms of, firstly, the GST, what they needed to do for the cost, the profit, etc., and then also how each of the numbers interacted with each other. So what we did actually find predominantly was the kids that were able to do it, they did clearly identify their total costs and or their income through clear and precise calculations. So because it was a multi-step problem, if the kids were able to break down each part of the question to the key components, they tended to do a lot better than students that were just randomly putting numbers together that they thought would actually go together properly. So one of the positives that did come out that the kids that did do the calculations tended to do a little bit better. And a number of the kids did identify that the profit did come between the difference between the costs and the income, but they were let down in terms of what was the total costs, what was the total income, but they did identify that profit was the difference between the two. So that was a positive that did come out of this particular question. Errors that they did tend to make was obviously with calculating the income or calculating the costs for the overall calculation for the profit. So they weren't able to apply the time correctly. So a lot of the kids weren't identifying the 10 hours came into play for the total income, the costs and the comparisons between the two. So they're actually just getting muddled up with all of the numbers that are actually part of the question. And that's what the next part is, that they just seem to randomly put the numbers together to find income or costs or even the profit. So what we'd be suggesting with this is GST was a concern again. What we did see, a lot of kids were obviously not using the 10% correctly with their calculations. So they were using it mathematically. They might be writing it down correct, but they could not use the 10% GST and calculate that correctly as part of their question. And also just what they're putting the 10% to. So they, moving forward, we need to see kids actually correctly calculating GST. And obviously, because it's not included with this value, it then needs to be added to the final value at the end. So there were a few little issues with GST, showing all their correct working out. So what I would be suggesting, and again, this is after seeing quite a few papers for this, what I'd be suggesting is that the kids are actually shown to separate each of those components individually and then bring them together at the end. We did see some students try to put all of the calculations together to try to find their profit in one line. We tended to see that there are a lot of numerical and calculation errors if they try to do that. But the better students were able to clearly identify their cost separately to their income and then use those values later to find the profit. So that's the suggestion moving forward, predominantly for standard 1, breaking the question down into each of the key components and taking it through from there. All right, standard 1, question 24. Now, with question 24, it was a nice little scale drawing. Units were in millimeters as it was clearly described within the question. And they were asked in the first bit to find the internal length and width in meters. What was quite good with this is the sample answer gave it obviously 5 meters and 3.6 meters. The vast majority of kids were able to identify the right values, but were unable to correctly convert them into meters. All right, so with that particular part there, they were able to identify the correct values, and they did actually take the 5,000 for the internal width of the main bedroom, which is great. Not many kids were using the 5,700, but we did see a number of kids obviously use the 5,700, but it was about the not converting into meters is the biggest concern. So we've always had with standard, the conversion of units is and has been a concern. And obviously with the diagram being very clear that it was in millimeters, the conversion to meters obviously is incorrect. But then with the kids that did try to convert it, they were actually incorrectly converting them into meters. So a number of kids were dividing it by 100, they were dividing it by 10. They weren't, the kids that were doing it divide by 100 and then by 10 were getting the right answer. But the incorrect conversion from millimeters to meters was a concern moving forward. So just like I was just saying then, students still need to be practicing the conversion of units. Identification, the correct values, that was great. But the conversion was obviously the key for that particular question. Now, what then happened with 24B, they obviously needed to carry through from their previous answer. If they were incorrectly converting the values, if they were incorrectly using those values for the 5.7 meters instead of the 5 meters, they could still end up getting awarded marks for this because it was a carry through. The biggest concerns with this, I actually found this to be a very tricky question for the kids because it involved 2 parts. They had to identify that they had to take away an area of the flooring that was not going to be carpeted. Even though that value was given, the kids or the students missed that. And then the second part that was quite tricky was that they needed to round up their answer to the nearest square meter to find the total cost of carpeting. So the conversion from 16.4 square meters to the correct answer of 17 square meters to find the correct cost was missed by a lot of kids. So it's about practice. It's about practical examples. And obviously carpeting is probably going to be a good one moving forward for standard 1s as well with standard 2. So what we did find is that most kids were able to find the area of a plane shape with this. So it could have been the rectangle or the area of the entire lounge room, not or including the area that was not to be carpeted. And students were able to then actually break it up into smaller parts. That was actually quite good to see. If they didn't correctly find the area of the carpeted to be laid, so they forgot the 1.6 or they used the wrong units from earlier, they still understood that they needed to multiply that by the $40 to find the total cost to actually carpet the main bedroom. So overall, look, the kids were able to do relatively well with this, but there were some key parts in there that were tricky for a standard one student to pick up. So again, what I've said is the errors that they didn't deduct the wardrobe from the total area to be carpeted. That was one of the biggest thing, not rounding up. But again, obviously they were what I thought were some tricky parts to this particular question. So with this, again, it's about some practical examples for the kids to try in class, applying mathematics to the skills to the real world. These are obviously quite common now. And then also the minimisation of costs for this. So it's just about getting the kids to do some practical questions within a classroom based upon the theory that we actually do. All right, the last one in standard one was a container with the filling of water. Now, with this, in terms of the graph was actually provided to the kids, they just need to actually draw onto it. Now, it did say after 5 minutes, or it takes 5 minutes to fill the larger cylinder. So we did see some kids do the graph upside down. So they actually thought it was a smaller cylinder filling first, perhaps. And with it being a possible graph, what we were what we were hoping for was obviously the straight line, a linear graph with a change after 5 minutes. Now, with this, what we did see is a lot of students did indicate a change in the rate after 5 minutes. Some of it was linear, well, most of it was linear. Some of it was non-linear graphs that were being provided. But most of the kids did actually identify that there was some sort of change in the rate after 5 minutes. Some thought it decreased, some others thought it increased. A number of students thought that there was no change in the rate at all. But the vast majority of kids did identify that there was a change in rate after 5 minutes, which was actually quite good. Now, common errors for this was if they were drawing a linear graph or a linear relationship for this, a lot of the kids were not using a ruler. So again, anything for graphs, the kids should be encouraged and strongly suggested that a ruler is being used for any sort of linear graph. And because the graph is obviously provided to them now, they don't need to draw the axes up. It's just drawing it straight on there. And other errors, which were not too many, but there were still a lot coming up, that because there was no change after 5 minutes, it didn't identify that the kids understood that the different shapes had a different rate of filling. So that's just something else to consider in terms of the shapes. And then obviously something to move forward is just to develop a better understanding of how rates of change differ between shapes. And again, that's just a bit of practice with maths in real world situations, just like the total cost to carpet the bedroom. Getting the kids more examples and more practical applications for that. Okay, so that is all of the standard one questions that we were looking after. And now we'll move into the standard two. Now, the standard two questions, question 16, very early in the paper. What we found with this one, the formula was provided. So with the volume of the sphere being provided and they're being asked to work out the volume of the hemisphere down the bottom, or half of a sphere, they're actually being told very explicitly within the question. And you notice that even with the radius being given to them with the formula and that it is half a sphere, a lot of the errors that the kids made in this was not halving the formula, incorrectly identifying the radius within the question. Some kids converted that to 4 meters. They were getting confused, obviously, with diameter and radius. They weren't cubing it. They're actually incorrectly copying and writing down the formula from slightly higher in the page down, and they were converting it into squares. And obviously they were forgetting the half. All right. So there were a lot of errors that were actually coming up on what seemed to be a very straightforward sort of question. So what was positive, if the kids wrote down the correct formula, they then showed that they correctly substituted into the equation, they tended to do the right thing all the way through. So being very methodical, copying it down, taking time and care with that formula. And again, they didn't have to go through the formula sheet to try to find out the right formula for this. It was all given to them. Other errors, not reading the question. And with all the information directly above, and we know that the kids are stressing out in a HSC exam, but everything was provided within that question to allow the kids to get some very straightforward marks. not having their solution or using the given radius, and that's what I was mentioning beforehand, and incorrectly using the given formula. So as I said, they were converting or changing the cubes to a squared. They might have been changing the 4/3. So there was a lot of manipulation going on with that formula, and that was leading to a number of errors. What we strongly suggest with this, obviously, is show all the working out. So by showing all the working out, they tended to make less calculation errors, because as soon as you do the half, you got everything else in there with the cube. And because there's really no decimal values with the radius, it became nice and straightforward. And those were the better responses if they provided all working out with the substitution correctly seen, less calculation errors came out of it. Right, so overall, the question itself was done relatively well, but there were some very fundamental errors that were being made by a number of students. Right, question 29 in Standard 2 was the wonderful algebraic equation that they needed to go through and solve with a fraction. Now, with the sample answer, what NESA were looking for in the examination committee were that they wanted to see a fraction using a common denominator, and that's where the better sort of responses came from. Now, with this, we would identify that common errors would be moving of the 2 across, maybe moving the -1 across in the first point. The better responses were obviously those that actually carried through their answers all the way through, and wherever they may have made an error, they might still be able to pick up marks depending upon what they show. All right, so obviously we want to see fully worked responses for any sort of equation coming through. Now, generally, when working out was used, they tended to do quite well. All right, so it's worth 2 marks, but if working out, the kids generally ended up getting marks, if not full marks for this. The better students, those that did actually represent the left-hand side of the equation as a single fraction, tended to do better. Now, what we did also see is kids moving the x across and leaving the fraction on the left-hand side and making it 9 minus x, and that was really good to see. So we tended to see a lot of kids making at least an error in their working out at some point. And I think for a Standard 2 student, would be expecting that for a complicated or most equations to solve, especially when there's fractions involved. What we did tend to see, and this was a common error, we noticed a number of standard kids actually trying, and I'm going to say this very loosely, a guess and check technique to go through and solve it. Now, the guess and check technique is probably not appropriate for this sort of equation, because it comes out to be a relatively comfortable numerical value at the end. But we did see kids just randomly putting a single value in there for x and expecting close enough is good enough. So they might have put in 6, and they'll say, oh, it's approximately equal to 6, so we're happy. We didn't really see any real guess and check techniques where they substituted in a value, refined it, checked it, guessed again, and refined it all the way through. So they weren't really using the guess and check technique, but they were randomly guessing an answer and seeing if it was a good fit. So with an equation like this, the guess and check technique is probably not the most effective or most appropriate way for this, but we did see it a fair bit. And then the common error, as I said, adding 1 to both sides or just multiplying both sides by 2, but forgetting the x at the start of the equation. And that would be a common error that we would probably all see. So they multiplied the fraction by 2, the 9 by 2, but obviously forget that first x and forget to double that. And then adding 1 to both sides because I think they can just move that 1 across. So they were pretty much the common errors. With this, learning outcomes for this particular question, just reinforcing, and I know it's almost ad nauseum that it gets brought up, when multiplying and solving any fraction within an equation, make sure everything within the fraction in the equation is being multiplied by 2. So it's just making sure that the kids don't forget one particular part, and we're all doing that. It's just the kids tend to still forget about it in an exam. The other part that was a little bit worrying about is that they weren't using the opposite operation to solve the equation. So some kids, instead of adding 1 to both sides, they're actually taking it away. Instead of taking an x away from both sides, they're actually adding it. So we saw that quite regularly. So it was still a bit of a concern moving forward. So again, it's about reinforcing that when we are solving an equation, we are taking that value away from both sides to obviously cancel it out. So there's a few little hints for solving an equation with standard 2 that we saw last year. Okay, question 30. Now, question 30 was involving shares, dividend yield. Now, dividend yield, I think the definition for that is lost on a number of students within the state in terms of not only where is it calculated from, but what does it actually mean? So dividend yield, a number of students were not representing it as a percentage. They may have actually represented it as a dollar amount. So they weren't recognizing that it was a percentage that we're after. The values within the question, the 1,500 shares, the $27 market price, and the dividend, those numbers were used in a variety of ways. And we believe that it was the kids not being able to interpret what is meant to be used to find the dividend and then ultimately the dividend yield. So they're actually just trying to randomly guess what values went with what and then trying to end up with a correct answer. So with this particular question, the language is probably the biggest thing that the kids need to be able to take out of it in terms of what is the dividend, what is the dividend yield, and what do each of those other values refer to. But if the kids got it, they knew exactly that most kids were able to find the dividend per share, or they were able to find the total value of shares. So the students were actually able to, and I'd say the majority of the time, able to get into part of the final solution. The next step was probably the issue in terms of what do they do with either or both of these values to find the dividend or the dividend yield. So like I said earlier, the dividend yield not representing it, as a percentage rather than a dollar amount was a major concern. Students were able to progress partway through the answer, but they tended to get lost on that very last part for converting it into the percentage, or as I said, that they were representing it as a dollar amount. So with this particular question, I'm sure it's probably come up in the past, it's actually the language, getting to know the terms, what do they each mean? And then obviously once you get to know the terms and obviously a little bit more practice in terms of how we find it, they'll actually be able to do a lot better. But it's the language use, I believe, within this question. And then not forgetting that dividend yield is a percentage. So obviously not representing it as a percentage if they actually answered the question. So that's just something to move forward with. All right, question 32A in standard 2 was a nice right angle triangle within a semicircle. Now, part A, which is the first little bit here, finding the length of XY, in all honesty, the kids generally did this quite well, right? So the kids that actually showed the working out, they were able to identify the correct trig ratio, whether that be right angle trig or non-right angle trigonometry, and they were correct in finding the right side within the triangle. They tended to do quite well. So the use of the right angle trigonometry was done quite well within this particular question, if everything was set up at the beginning. So the biggest part of this question that we thought, and I'll go through the positives first, if they're able to identify the correct trig ratio, they tended to do quite well. And if working out was used to support their trig ratio, they were able to clearly identify the sides, whether they use sine or cos, or even the sine rule, they're actually able to go through and find the correct side within the diagram, which was XY. If without that sort of methodical working, they tended to lose plot and not find the correct side, but then they were able to use that in the next part of the question correctly. Right, so they may have found one of the other sides within the triangle, obviously not answering this question, but they still needed it for the second part. And obviously not finding the correct side was one of the sort of common errors within this particular question. And it came down to obviously not identifying the key sides on the triangle based upon the angle provided in the question, or if they found the other angle and then identifying the opposite, the adjacent, the hypotenuse by using either the 30 or the 60 degrees. And the other error was that they weren't justifying their answer, right? So they weren't calculating it. They weren't doing any substitution. They might have written down 12. They might have written down 13. They may have written down any other number. So they might have been making something up. It's really important just to identify how they've gone through and use the correct trigonometric ratios to find this. So moving forward with any sort of trig question, they need to be able to identify and correctly name the sides of the triangle. And by doing that, they're able to identify and select the correct trig ratio rule. And because they're all on the formula sheet, it should actually be a little bit more easier for the kids to move forward with that. Other big thing, got to ensure that the kids' calculators and standard are actually in degree mode. There were a number of kids that actually did have correct working out, or at least what we thought was correct working out from their calculations, and it could have been in any other mode. So just please reinforce that the kids' calculators must be in degree mode, and obviously make sure that they're referring to the formula sheet. If they're using the sine rule, make sure that they're writing sine in there. If they're using the cosine rule, make sure cos is in there. So some of the kids are actually transcribing the formulas from the sheet onto the exam paper and mixing up sine and cos, or even opposite, hypotenuse, adjacent, etc., in the wrong way. So the transcribing is also a bit of a concern. Now, 32A carries straight over to 32B. Now, 32B was to find the area of the shaded region based upon the semicircle and the triangle. Now, with the two parts, they needed to work out the area of the semicircle, work out the area of the triangle, and then take them away. When I say this, we had a number of students do this, and the shaded areas are not semicircles. We had a lot of kids try to find X, Y, and Y, Z either from their previous answer or go through and recalculate it, and then work out the area of those semicircles and then add them together. Now, these are not semicircles. They could be construed as being minor segments. They are definitely not semicircles. So it was unfortunate that a lot of kids actually looked at it like that. So the better students were able to identify the radius. So rather than the earlier question that we looked at, where the radius was already provided for this hemisphere, with this one, they were given the diameter. They had to find the radius from that. So one common error right at the start was incorrectly using the diameter to convert to the radius to find the area. So we saw a lot of 1/2 of pi times 16 squared. The kids were able to find the area of the triangle either using right angle trig. So if they found ZY in the first bit, and then they went through and found YX or vice versa, they were able to work out the area of the triangle using 1/2 base times height. Perfectly fine. The better kids did use the trig, so 1/2 AB sine C for working out the area of the triangle, and then by doing the subtraction. The unfortunate part is the kids that went through and used a right angle triangle to work out the area using 1/2 base times height, unfortunately chose to use 16 as the height of the triangle. So that was one common error, that they weren't identifying the correct sides in that right angle triangle to find and use the base and the height to work out the area. So that was one common error that came out of that. But the good thing is a lot of the kids did identify that it was the semicircle minus the triangle. And if they're able to work out the area of their semicircle minus the area of their triangle, they were still able to actually achieve because they understood what they were meant to do with this question. All right, so the positives were they were able to identify the area of the triangle and area of the circle and subtract them, which was good, in the right way. A variety of techniques were used to find the area of the triangle, which was perfect. So the kids, because this was common, the kids were able to find the area of the semicircle and the triangle in a variety of ways, which allowed standard students and advanced students to use their own sort of techniques quite comfortably. Incorrectly finding the radius, as I said, not justifying this final selection. We did see a lot of kids actually just write down a final answer. Now, with the final answer for this, it's not a good technique at all, because the kids should always be shown working out to do this. Irrespective of how or if they guessed the correct answer, they need to always be supporting their answer with correct working to get to that point. Using the 16 as the height of the triangle. Yeah, as I said, the shaded areas were both semicircles. And the other part is the hence. Now, with this particular question, because it just says hence find the area of the shaded triangle, shaded region, the kids are expected to use their previous answer. If it says or otherwise, there are alternative techniques there. So the reason why XY was provided as part of the earlier question is that that would then lead them very easily into using 1/2 AB sine C to work out the area of the triangle without too much discomfort. So even getting to know the language within the question, what the examiners are trying to get the kids to do, is always a good point of call for when we see hence or otherwise. And the last little bit moving forward for these sorts of questions where they're multi-step, without too much sort of direction given, just be methodical in terms of the way the solution's set out. Number of kids were doing, students were also doing the area of the triangle minus the area of the semicircle. So they were getting it around in the wrong way, and a variety of different variations. So if they're methodical in working out, here's the area of the triangle, here's the area of the semicircle, and following it through, making it as clear as they can, those students tended to do a little bit better because they were able to identify it very clearly. Okay, next question is, for me, is 33AI. Now, question 33 itself was quite interesting to see the responses all the way through. So I'll take you through what we saw and then about what the expectations were. Now, for the first one, the students were given a whole bunch of information there. They were given a regression line. They were given the equation, the regression line, so they didn't need to find the gradient. They didn't need to find the y-intercept. They didn't even need to find the correlation coefficient. So the first part was actually just substituting in a value into the equation that was already given as part of the question, and then basically pressing equals. So for this, what we did actually see, look, in all honesty, I thought this was a very straightforward question for the kids to get through. We did see the students using the graph to find the value. And because the question actually says by using the equation, the expectation was the equation and the substitution need to be provided to get them to the correct answer. So a number of students did draw on the graph and write down an answer that was numerically incorrect. So it's about, again, the kids identifying within the question, what are they expected to use? But the graph was always a good backup to make sure that their answer was appropriate from their substitution. We did see students putting in random numbers from the question. They might have substituted in 17. They might have substituted in the minus 0.494. But obviously they weren't substituting in the correct value. Those that did obviously got the right answer, and they're able to calculate it very easily. So it's about just, again, getting the kids to read the question, identifying what are they expected to use to solve that particular question. So part one was pretty straightforward, or at least in my opinion it was. Part two was a little bit more complicated because it needed the kids to identify what the gradient in this context actually meant. So not finding the gradient, but understanding it. And this is where a number of students gave a variety of responses, but in the sample answer, we're looking for 1 metre increase in the height above sea level. We can expect a 0.0011 degrees Celsius drop in average max daily temperature. It was very, not a great deal of students were able to be explicitly, able to explain themselves explicitly with this in terms of the decimal value. A number of students were actually able to tell us that there was a decrease in temperature as there was an increase in height. So they were actually showing an understanding for it, but they weren't able to take themselves to the next step about identifying the numerical values based upon the gradient, right? So it was about understanding a decimal value for what the gradient refers to. If it was a fraction, if it was 1/4, it might be a little bit more easily accessible. But in terms of this, it was about getting to know what the gradient referred to, how to use it back to the graph, and then obviously what the comparative fractional value would be able to do. So this was a little bit more harder for the kids to interpret. So overall, so looking at all of 33A, they were able to use the equation correctly, which was part A, part I. They didn't substitute, not calculating their substitution correctly, so that was all for A, part I, using the graph, as I said. Even for both parts, just taking care of their working out, and predominantly with A, part I, getting the kids to know exactly what the gradient is referring to, going deeper in terms of comparisons and explanations. So A, part I was a tricky question for kids to interpret and explain with mathematical notation and language. 33B. Now, 33B obviously carried on, and for 1 mark, there's a fair amount of reading on there, and it just carries on that they're converting or comparing one graph to another type, and they're talking about whether or not the height above sea level or latitude would be better. So there were actually 2 parts that they needed to do for this. They needed to identify and be clear with, was it height above sea level or latitude, and why? So again, with this, what we did tend to see is the kids weren't clearly identifying which response that they're choosing. So they were writing height, or they were writing above. They may not have said latitude. They may have said average maximum temperature. So they were getting confused with what they were expected to provide. And then how they gave a reason for that was based upon it had to be something dealing with correlation. So the stronger the correlation, that could have been a variety of things. So how would kids in class describe correlation? It could be based upon the numerical value for the coefficient. So R being minus 0.0897 is closer to -1, which means it's stronger than the other one. So we're looking for a comparison because we needed to see that there was a reason why one number was better than the other. Common errors for this were kids were saying that a stronger correlation is closer to 1. So they were missing the point of the question here that they were both negative values. And I think that just comes down to the kids become more confident with positive values for correlation. So suggestion moving forward is get more negative correlation coefficients into the kids' practice, etc., so they can then understand that it's closer to -1 becomes a stronger correlation. They may have been describing the position of the dots closer to the line for one graph compared to the other. So that would also indicate that the correlation is a lot stronger from one graph to the other, but they needed to give both. They needed to give their solution being height above sea level or the latitude, along with a valid reason that was linked to correlation. So moving forward for this particular question, students were able to identify the correct solution in 33 in the first part. When they used the correlation to compare, most students were able to compare between the two relatively correctly, except for those students that went on to describe it that it was closer to 1, or when they didn't make a comparative statement between the two types. Why was one stronger than the other? So they had to be comparing between the two. All right, other parts for this were kids were actually making a justification based upon geographical reasons. So they were saying 25 degrees south is colder or it's hotter as you go lower. It had nothing to do with geography with this. So because it was obviously a maths response, the examination committee needed to see something based upon correlation being as the description, not a geographical reason for this. The other part, as I said, about when comparing, make sure that it's stronger as it approaches -1, not closer to 1. And then the final part is learning outcomes, identify ways of statistically comparing data sets using correct language. So anything to do with stats, especially with a justification or a compare sort of question, make sure that the kids are using the correct language. They're using the numbers and they're comparing the numbers along with the correct language. And that makes them get into makes it very clear to the markers, gets them into the marks that they obviously deserve, and it shows that they have a deeper understanding for the question. So anything to do with justification, make sure that all the kids are using calculations with the correct mathematical language to get the full marks. Okay, that's it for me. Hopefully you've been able to get something out of it. Thank you.